Bohr atomic model and the models after that explain the properties of atomic electrons on the basis of certain allowed possible values. The model explained how an atom absorb or emit radiation when electrons on subatomic level jump between the allowed and stationary states. German-born physicists James Franck and Gustav Hertz obtained experimental evidence of the presence of these states. In this lesson we are going to study: what is Bohr's model of an atom? What is a nucleus? What are the charges on proton, neutron, and electrons? What is orbit, shell or stationary orbit? What is energy level and what are the different energy levels? What is the effect on electron when it gain and lose energy? What is Bohr's model of an atom? According to the Bohr atomic model, an atom consists of a small positively charged nucleus and it is surrounded by revolving negatively charged electrons. The nucleus contains positively charged protons and uncharged neutrons. These electrons are revolving in fixed orbits. Electrons revolve around the nucleus in a fixed circular path termed orbits or shells or energy level. The orbits are termed as stationary orbit. Number of electrons are equal to the number of protons, hence the atom is electrically neutral. He concluded that an electron will have more energy if it is located away from the nucleus. Means electrons in the higher orbit have high energy, whereas electrons located near to the nucleus have lower energy. The electrons will not radiate energy as long as they continue to revolve around the nucleus in the fixed orbital shells. The different energy levels are denoted by integers such as n is equal to 1, or n is equal to 2, or n is equal to 3, and so on. These are called quantum numbers. The range of quantum numbers may vary and begin from the lowest energy level to the highest energy level. The different energy levels or orbits are represented in two ways. One way is by numbers as 1, 2, 3, 4. And another way with shell name is K, L, M, N. The lowest energy level of the electron is called the ground state. Orbit, energy level, is represented as K shell and it can hold up to 2 electrons. This shell also has subshell. K shell has one subshell named S and it holds 2 electrons. Second orbit, energy level, is represented as L shell and it can hold up to 8 electrons. L shell has 2 subshells such as S and P. S subshell has 1 orbital and it holds 2 electrons. P subshell has 3 orbitals, each orbital has 2 electrons, thus P has total 6 electrons. In this way L shell holds 2 plus 6 equals 8 electrons. Third orbit, energy level, is represented as M shell and it can contain up to 18 electrons. M shell has 3 subshells named S, P, and D. S subshell has 1 orbital and it holds 2 electrons. P subshell has 3 orbitals, each orbital has 2 electrons, thus P has total 6 electrons. In this way L shell holds 2 plus 6 equals 8 electrons. D subshell has 5 orbitals, each orbital has 2 electrons, thus D has total 10 electrons. In this way M shell holds 2 plus 6 plus 10 is equal to 18 electrons. Fourth orbit, energy level, is represented as N shell and it can contain maximum 32 electrons. Here we have considered silicon atoms, so K shell holds 2 electrons. L shell holds 8 electrons. M shell holds 4 electrons. Number of electrons are equal to the number of protons, hence the atom is electrically neutral. The change in energy occurs when the electrons jump from one energy level to other. In an atom, when electron gains energy by any means, the electron will move from its lower orbital energy level to higher energy level. However, when an electron loses energy, it moves from higher energy level to lower energy level.